Hi everyone, this is Parabolas Day 3. So we're going to start by taking a quick look at the answers to Parabolas number 2. And this is the last day of Parabolas before you'll get into some review. And then by the end of the week, you will be taking a test on circles and parabolas. So this is the actual assignment that I hope you've completed at this point. And then here is the answers. The first section was writing the equation of a parabola given certain criteria. The idea behind all of those was that the focus was given in certain cases, but more importantly, the vertex was always at 0, 0. And that's pretty much what's going to be the only difference in today's lesson, is that you'll see that we're going to move the vertex away from being at the origin. We're going to write equations based on that. So here are the answers to the first section. Then you had to do some where you had to potentially complete the square to get it in standard form. This one you did not have to complete the square. Be careful that when you factor out a -4, that changes this to a +2, right? You can quickly double check by distributing that back through to see if you get what you had in the prior step there. And then here's all the critical info associated with that sketch. So there's the first one. Okay, looks like there were 5 total in that sketching section. So in number 2, you also did not have to complete the square on this one. Move some terms over, take out the -16 as the GCF. There's the critical info. In number 3, you did have to complete the square. Just carefully make sure that when you get the vertex, you get the x coordinate from the x's, the y coordinate from the y's. So is it 0, 3? Remember, if y is squared, it's going to open left and right. Okay, 4, and then also 5 you had to complete the square with. So kind of slowly move it up so you can see those. Okay, I had to squeeze 5 all the way at the bottom there. So if you have any questions about this homework in particular, this really has, pretty much a vast majority of what you'll see with parabolas. But like I said, we are going to move on today and talk about what if we were to work backwards and the vertex was not necessarily at the origin. One thing before we get there, though, is, if we were in class, I would have a warm-up question for you today. So the warm-up question says, sketch and identify the critical info for this parabola. If you just checked that homework and it didn't go so hot, or if you just want another example for practice, here's a really good one just to make sure that you're good with completing the square, getting this into standard form, and identifying the critical info. So I'll just walk you through the answers quick. Now's a good time to hit pause and try it if you'd like to. But here's what it looks like when you complete the square. So we're going to get it down to this step right here. So the vertex is at -2, -4. Since the value of a is positive, it opens up to the right. A is 1.5. And then based on that value of a, we can get the coordinates of the focus, the equation of the directrix, and then the ends of the LR. I don't know how you guys feel about the fancy way of writing those coordinates, like I mentioned in the last lesson. So if you feel like you're in a good place to use that fancy format, then go for it. If you're like, nope, I definitely want to just keep them separated, that's fine as well. Something that might look a little bit different that I probably haven't used yet is that I've been labeling the ends of the LR as E and E prime. So that's what that represents. If you want to use those abbreviations, E and E prime, for ends of LR, that would be fine. Okay. Okay, so hopefully that makes sense there. And then we're going to get right into today's notes. So this blank sheet will be posted right next to this video on the website. So if you want to print it off and take notes, if you have a printer at home, go for it. If not, you'll just take them on a separate sheet of paper. So what we're going to start is recalling what are the general forms of a parabola. And we have y-axis symmetry versus x-axis symmetry. So y-axis symmetry, meaning it's a vertical parabola, it either opens up or down, is going to be the x quantity squared equals 4a times y minus k. And then on the other hand, if it's a horizontal parabola, meaning it opens to the right or left, it would have x-axis symmetry. Then it's going to be the quantity y minus k squared equals 4a times x minus h. What I would encourage you to do is hit pause real quick and think about what are the 3 things that we need to write the equation of a parabola. See if you can list some or all of those, and then hit play again and see if you got either all of them or at least just some. Something you definitely have to know is the coordinates of the vertex. Okay, we're going to plug that in for h and k. They don't have to go in this order, by the way, but next thing we probably want to figure out is what's the a value. Okay, because the a value is going to lead us to eventually multiplying that by 4 to put that into the equation in these two locations. And the last thing you have to know is which way does the parabola open? If it opens up or down, we're going to use this format. If it opens left to right, we're going to use that format. And don't forget that sometimes a could be a negative number. That would be if it opens down or to the left. So just make sure you're keeping track of all of those items there. So if we take a look at number 1, I will tell you it is not a requirement that you use the grids. I think it really helps to use the grid forms. Okay. So when you take the test, I usually would give out a scrap sheet of paper, graph paper for students to work with on these types of questions. If you have scrap graph at home, use it while you're taking the test. If not, no big deal. You can get around not having it. So we have a vertex and focus given to us. We can use that to write the equation. So I'm actually going to draw some axes over here, 3, -2, and then 3, -8. Let's say that 2, 3 is right here. Okay, there's the focus and there's the vertex. So when I'm thinking about my list of the 3 things that I need to know the vertex, the value of a, and which way it opens. You know, even just based on those 2 points, I know those 3 facts. Well, we already know that the vertex is 3, -2. So we can check that off the list. The value of a, well, we need to be really confident that a is the distance from the vertex to the focus. So if I count this distance from vertex to focus, the value of a in this example winds up being 6. Now you might want to consider listing it as -6 since the focus is below the vertex. So I'm going to say that a is -6. And finally, since the parabola wants to eat the focus, I might have used that phrasing in the last lesson, this graph is definitely going to open down, which if you don't list the value of a as -6, it's not a huge deal, but you have to negate the value of a when you plug it into the equation because this opens down. So the end equation would be, based on this vertex, x minus 3 squared. Okay, it's an x squared equation when we open down, equals 4 times this, so -24 times y plus 2. And that's it. You're not supposed to do anything else with this equation. We're going to stop there. And that represents this parabola with the vertex and focus that are given. In the next one, we know the vertex and we know the ends of the LR. So the vertex actually is the same coordinate as it did in the last one. Let's see. So we're at 3, -2 again. So we can check that off the list. And we've got -2, +1/2, and then 8, +1/2. So let's see, that would be 5, 7, 8. That would be over here. Those are the ends of the LR. And from the homework, you know, if you want to label those as E and E prime to denote that, that's sort of up to you. But once I know that these are the ends of the LR, although it's not given to me, I know that the focus has to be midway in between those endpoints in line with them. Okay, so now that I can see where the focus is, I can see that the value of A is up 2.5, right? So A is going to be 2.5. And it is going to be positive because if I connect the ends of the LR to the vertex, I can see that this is a graph that opens up. So if we have a vertex, this value of A, and it opens up, we have enough info to say that the equation is still x squared, x minus 3 squared equals 4 times A is going to be the value 10 times y plus 2. If you're feeling pretty confident with this idea, because it's really similar to what we did in the last lesson, even though the vertex was always at the origin for those, you know, feel free to pause and then come back later and just check some answers, right? So I'm going to keep going and finish the practice on the next page. And then we have one more thing to talk about here, which we'll eventually get to doing a little bit of write the equation of a parabola passing through some points. Okay. So in number 3 at the top of this page, it says the vertex is 4, 1. The directrix is x equals 2. Okay, so here's my axes. You can draw the axes wherever you really want, guys, but all right, 4, 1's the vertex. Directrix x equals 2, to be honest, I think that a lot of the mistakes tend to come from students forgetting the simple fact of, is this a vertical line? Is it a horizontal line? Okay, x equals is definitely vertical. So here's the line x equals 2. There's the vertex. Based on that, I can tell, well, I already know the vertex, first of all. But I know that this opens up to the right. Okay, the parabola will never cross that directrix line, so this is going to open to the right. And the last thing I need is the value of A. Now remember that A is not only the distance from the vertex to the focus, but it's also this distance from vertex to directrix. That's the value of A as well. So in this scenario, A would equal 2. And since the parabola is opening up to the right, A would be a positive number. Okay, opening up to the right means that value of A should be positive. So the only thing that's a little bit tougher here is, remember, if it's opening to the right, you need a y squared in your equation, and make sure that you pair y with the y coordinate from the vertex. This is going to be y minus 1 squared equals 4 times A, so that's 8, times x minus 4. Okay, moving on to the next one. We finally don't know the vertex. We've known it in every other example, but this time we know the focus and the directrix. Okay, focus is at 2, -3. So there's that. The directrix is at x equals 6, 3, 4, 5, 6. So there's the directrix line. And based on that, we should be able to write the equation of the parabola. Well, based on what we've seen so far with focus and directrix, I'm hoping we know that the vertex is midway in between, right? We have to have enough info to find that coordinate point. So given focus and directrix, focus in this case, sorry, vertex in this case, it's going to be the coordinate 4, -3. And now I can see that if the parabola is going to eat the focus, it's definitely going to open up to the left. And the A value in this case is going to be 2. But since we're opening left, I might call A -2. Okay, so when we open left, it's a y squared equation again. Make sure you get the y value of the vertex, y plus 3 squared. 4A is going to be -8 times x minus 4. Okay. Going a little fast here, so pause if something's too fast and you're still trying to catch up. This last one, to be honest, I don't even think I really need the grid for it. So what I'll tell you in the last one is we know the vertex is at 2, -3. Check that off the list. We've done somewhere it says it passes through this point. So it passes through the point 6, -2, and it has a vertical axis of symmetry. So what it means when it says it has a vertical axis of symmetry is that a vertical line is what cuts this parabola in half, which means that, well, I guess if I were to plot these, the vertex would be below this point. 2, -3 would be lower than 6, -2. So what I know is that this graph actually opens up. And the reason why that's important is that this also could have opened up to the right and connected to the point 6, -2. So that line where it says vertical axis of symmetry means that this is going to be one that opens up. So it's an x squared equation. And since I don't know anything, if this is a special point or not, right? It's definitely not the focus. It's not, we don't know if it's an end of the latus rectum there. So you have to be careful about assuming anything about this point. We just know it's like kind of like a random point somewhere on the graph. If this is the point 2, -3, 6, -2 might be over here. So without making that assumption that that would be an end of the LR, here's how we're going to do this question. You're going to start by writing the equation, x minus 2 squared, because we know it opens up, equals, well, the value in question that we're not going to know is 4a. And then that's going to be times y plus 3. And if you remember what I showed you in the last lesson, when you're looking at a parabola with a given vertex, if it passes through a point, set up the equation with the vertex plugged in. And then we're going to solve for 4a by plugging in the coordinate that we're given. So plug in 6 for x, plug in -2 for y, And if I solve this, 6 minus 2 is 4, and 4 squared is 16. Negative 2 plus 3 is actually positive 1. So in this question, you're going to get that 4a is equal to 16. I realize that that tells you that a equals 4. No problem there. But remember, what you're replacing in the equation is 4a. So if I divide the 4 out in this step and I get a equals 4, that's fine. But when I come back up here, I'm just going to have to multiply by the 4 again. So I'm going to write the equation as x minus 2 squared equals, that's going to be 16 times y plus 3. Okay. I think this question, when we go through it in this example, I hope it makes sense. But if I'm being honest, this is one of the most missed questions from students. You'll see it come up on the homework. You'll see it come up on the review sheet. So get a little bit more practice with it so you feel confident. And then if you have questions, you'll let me know. Last thing in this lesson is going to be the general form of a parabola that is vertical and the general form of a parabola that's horizontal. So what we've been looking at up until this point is what's called the standard form. In standard form, we can easily identify the vertex at HK. So what we're going to now look at is if it's a vertical parabola, it's going to be something like this or something like this. So that's going to be an x squared equation. So what we're going to see is it's going to be x squared plus dx plus ey plus f equals 0. Okay, that's the general form for a vertical parabola. And if that looks or sounds familiar, it's because it's almost the same as the general form of a circle. Maybe you know what's missing. Horizontal, meaning it's opening up to the right or opening up to the left like that. What we're going to see for horizontal is that it's going to be just the same thing, but with y squared out front. Y squared plus dx plus ey. Do you guys hear those screaming kids in the background? Maybe. They have a good way of interrupting pre-calc. They don't like to interrupt any of my other subjects, but for some reason pre-calc, they like to really turn up the volume. So, all right. So the only thing that would be different if it was a circle is you would have x squared plus y squared in the equation. You'd have both x squared and y squared plus the dx, ey, and f. But for a parabola, only one of the variables squared, so that's important to recall. It's either x squared or y squared.